Hello everybody. Today we're going to continue talking about the evidence of evolution. And for today's evidence, we're going to be focused on fossils. By looking at fossils and studying how organisms change throughout time, scientists were able to put together the geologic timescale. This is just the timeline of the entire Earth's history. We realized that many organisms lived and went extinct before humans ever roamed this planet. So, by looking at changes in fossils, we're able to separate all of Earth's history into segments of time. We call these periods, right? And we see on the timeline over here, some examples of periods would be like Triassic, Jurassic, Cretaceous, right? Each of these periods has like a group of fossils, and then all of a sudden you'll see a change, right? That at the end of one period and the beginning of another period, a new group of fossils will emerge. The timeline's also broken down not only into periods, but into eras, right? And at the end of the era, like Paleozoic, Mesozoic, and Cenozoic, you have a mass extinction event, right? For example, at the end of the Mesozoic era, we had the KT mass extinction right here. That was kind of between the Cretaceous and Tertiary periods. Right? The KT extinction happened about 65 million years ago, when an asteroid or a comet hit the Yucatan Peninsula in the Gulf of Mexico and caused 75% of all animals that lived on the planet to go extinct in a relatively short period of time. It was kind of like this prolonged winter that many of these organisms just weren't able to survive. So, by studying these fossils, we realized that most of the animals that ever lived on this earth are no longer living. Right? Over 99% of all species that ever evolved have become extinct. Right? And it's not humans' fault. Like when we hear about animals going extinct today, we always blame humans. But sometimes if animals just aren't able to, adapt to their changing environment, they die out. They go extinct, and it makes room for new animals to evolve. It's kind of a natural process here. So, let's talk a little bit more about fossils here. We have two ways to determine the age of fossils, to figure out where they go in this geologic timeline. Okay? The first type of method for figuring out how old a fossil is called relative dating. And this just asks the question, where is it in the rock layer? The deeper you have to dig to get that fossil, the older that fossil is. Now, this method doesn't tell you exactly how many years old the fossil is. When you find something, you say, okay, it's older than this, but younger than that. For example, in these rock layers over here, we see that S is closest to the surface. Alright, so we know that this is a more recent fossil. Alright, X is a little bit older than S. Alright, and then you have V, followed by M, and then Q, and then fossil Z, which is at the bottom of this rock layer, is going to be the oldest. Another method that we have for figuring out how old fossils are is radioactive dating. Right? And this does tell you exactly how old the fossil is in number of years. So, what scientists do to do radioactive dating is they look at radioactive isotopes, basically chemicals in the fossil that aren't very stable. Alright? So one of these chemicals they'll look at is carbon-14. Right? So this is just carbon that has a few extra neutrons in it that make it a little heavy. Right? But it also makes it a little unstable. So it takes 5,715 years for half of the carbon-14 to kind of decay. Right? That's called the half-life. Right? So, if we test a fossil and we find out that there's only 25% of the carbon-14 remaining in that fossil, we know that it has gone through 2 half-lives. Alright? So 1, 2 will leave us with 25%. Right? Well, 2 half-lives is 5,715 years times 2. So the scientists can figure out if that fossil is about 11,430 years old. Alright guys, that's it for today's lesson. Thanks very much. Bye.